Very good morning to all of you. Welcome you guys. Welcome you all. How you are doing everybody? I think we are live. First of all, do check करके बोलिए ना is the audio videos clear to everybody? Do check करके बोलिए now is the audio videos clear to everybody? Now, first of all, a great news to all the aspirants. Now, the Unacademy subscription that is just 7,999 only. And इसके साथ you will get 6 months plus additionally 1 month benefit आपको मिलेगा प्लस पर आइकॉनिक के लिए तो 10,999 only. Use the code of BV Reddy and to avail these great opportunities. And this is the last live batch which is starting from the 24th July onwards. You can see the top educators team आपको एक साथ मिलेगा. And so there is a chance to get the flat 90% of discount. We have the 2 sessions are there. You can see, and the exam is on 26th July. That is today. 2 sessions. One is at 11 a.m. The other one is at 5 p.m. So do enroll immediately. There is a chance to get flat 90% of discount. And we are starting the last live batch from 24th July से शुरू होने वाला is started from the control systems and networks we started. And to enroll for it, you can use the code of BV Reddy and to avail this great opportunity and to have a great learning experience. Yes, these are the rankers of ESC 2025 ka rankers. You can see these are the GAY 2026 ka rankers from cable from EC and electrical ka rankers. And so what we offer now an Academy Plus as well as Iconic. Plus में आपको क्या चीज मिलेगा? The top educators classes मिलेगा, live doubt solving होगा, evaluated test series, unstructured courses and live test, unlimited access. And Iconic में additionally क्या benefit मिलेगा आपको? Physical notes मिलेगा, personal coach भी आपको मिलेगा. So you can start the serious preparation with an academy to achieve your dream goals. An academy team of the top educators are there for you to provide you the best knowledge ताकि आपको आपका goals आसान से achieve करेगा. Right. Start your serious preparation. Let's crack it. Chalo, last class we have discussed some problems we have seen now. And the problems are these problems are helpful for the state government, SSC, JEE, and other state government exams. Like we can see now AE, AEE, for all type of exam, this course is very much helpful. And do attend the classes regularly. So I will take the classes. So daily some topics will discuss. I'm planning to discuss networks, digital, signals, controls, EMF. These 5 subjects I'm planning to discuss in the special classes daily like this. Okay, chaliye. And take the next problem. Last class we did the 40 problems. So now we continue the remaining problems. And all these are the previous year SSC, JEE question, like we can the state governments, AP, GENCO, Transco, and we can say, and other state exams, electricity department exams, right? Take down. The mutual inductance between two closely coupled coils is M. Oh, coil C is given as 1. If the turns of the one coil is decreased to half and those of other coil is doubled, then the new value of the mutual inductance. Hmm. Yeah, first of all, you tell me now what is the mutual inductance formula, you tell me now. Mutual inductance, and which will be equal to, that is K into, that is square root of L1 into L2. Here the coefficient of coupling remains same only. So that means we can write it as M proportional to what we can say now, square root of L1 into L2. Now they given this as a number of turns are they changed. So if we see the inductance for the coil, how it will be related to the inductance now number of turns. Now here inductance is directly proportional to the number of turns. Inductance is directly proportional to the number of turns. And they given this as a number of turns for the first coil. They made it as what, tell me now, decrease it to half. That means N2 becomes what, you tell me now here, N1. So it is becomes half now here number of turns. So then as usual, so this inductance will becomes, now I can say L1 dash will call. So this is new inductance which will becomes what, tell me now, L1 by 2. Now L2 dash which will becomes what, tell me now, the other one is doubled. So this other one is doubled. So will becomes what, you tell me now. So that is 2 into L2. So from this, what we can write, you tell me now here, the new mutual inductance, if I say this is M2 by M1, and which will be equal to what we can say now, square root of L1 dash by L1 and L2 dash by L2. So you can tell me now M2 by M1, and which will becomes as square root of L1 dash is how much now? This is L1 by 2 by L1. L2 dash is, that is 2L2 by, yes, L2. So this value will come to be a what, tell me now, 1. So that means from this what we can say now, M2. How much will be the M2 will come, you tell me now. M2 which will come to be a M1 only. M2 come to be a M1 only. Yes, so that's why new mutual inductance is same as the previous one only, which is equal to 1H. Okay. Next one. And see the next problem what they given. Two inductors have self-inductance is given 9 and 25. The mutual inductance between the two coils is 12. The coefficient coupling. So here coefficient of coupling, the relation which is given as mutual inductance M, which is equal to what, will be now K into, so square root of L1 into L2. Coefficient of coupling K, which will be given as what, will be now here M by, that is square root of L1 into L2, that is K, which will be equal to M. M is a mutual inductance which is given as a 12 by, so square root of what, will be now 9 into 25. So that means K which will be equal to 12 by 9 root is 3, 5 now here. So this is, we cancel it now here, cancellations, 3, this is 4. And which will come to be a K value is what, will be now 4 by 5. So this means 0.8. Coefficient of coupling is 0.8. Next, the equivalent resistance between the terminals X and Y is. Now you can see now first of all bridge. Now here we can say this is my R1, this is R2, this is R3, and this is R4. Yeah, you can see now this is R1 by R2, which is equal to what? Tell me now, R3 by R4. So that's why we can call it as a balanced bridge now. This is the balanced bridge. In case of a balanced bridge, see what will happen now. This diagonal element. So this element we can remove it now. Now see the next element, next connections now here. X and this is Y. So this is 5 and this is 15 and this is 10 and this is 30. So you can tell me now here how much we'll get now. These two are series, means 20. This value is these two series now 20 it will becomes, and these two also series, so it will becomes what element of 40. Now again parallel, so that means the RXY which will be equal to that is 20 parallel to 40, 20 parallel to 40. So then will come it as RXY, which will come to be a 40 by 3 ohms. Next one. The three resistances 5 ohm each are connected in star. The value of equivalent delta resistance. All values also same only. Now delta connection, if we have connected this thing, as I told you now, if we call this resistance is R1, tell me the R1 ka formula. I told you how to write the R1 formula, isn't it? That is R1, which is equal to this is 5 plus 5, sum of these two, and product of those two, 5 into 5 by other resistance na 5 will get cancelled. So that means R1 will come to be how much now? 15. So this is option. Next one. A 120 volt 60 watt incandescent lamp has to be operated from 220 volts 50 cycles per second one phase AC supply. In order to do this, a circuit element has to be connected in series with the lamp. Which one of the following series element is preferable? Oh, wow. Hmm. So a 120 or 60 watt incandescent lamp has to be operated 220 50. A circuit element has to be connected in series. Hmm. Then what has to be connected now here? Hmm. 220 volts has to be operated from 220. Okay, so the following element is preferable. Yes, inductance is preferable and capacitance is also fine. And what they are saying here, okay, resistance. If we do resistance, there is a power loss now. If we did the resistance, resistor will make a power loss. Now, if we have connect the inductor or capacitor, there is no power loss, isn't it? So that's why a resistor causes the loss of power. Resistance causes the loss of power. Okay. Now, so inductor and capacitor doesn't cause us. So that's why. So pure inductor and pure capacitor causes no loss of power. No loss of power. So that's why we'll prefer, what element will prefer now? We'll prefer the inductor. Capacitors are preferable. Yes, inductor, pure inductor or pure capacitor, we can be connected. Next one. Resistance, temperature, coefficient of copper. So then temperature coefficient of copper at 20 degrees Celsius. And this is the one fixed value you need to remember. Temperature coefficient of resistance of copper at 20 degrees Celsius, which is equal to this much. Alpha, which is equal to 0.00393 per degree Celsius. So this value, fixed value, need to remember. Sometime they wantedly they will do this type of questions. Next one. The mutual inductance between two coils having self-inductance 3 and 12 and coupling coefficient is mutual inductance. They ask him to find M. So tell me the mutual inductance formula first of all. That is K into square root of L1 into L2. So you can tell me now here, which is equal to K value 0.85 into square root of L1 3 into 12. So then this M value will come to be what, tell me now? 0.85 into square root of 36. 36 means will come it as 6 now. So this is 0.85 into 6. Yeah, tell me how much will come here. So this is 30. So this is 0.85 into 6 now. This is 30, 11 or 51. So this is 51. So we can say this as 5.1. Option B. Done. Next one. The unit of reluctance is reluctance. Yes, now here we have like a electric Ohm's law. What is the electric Ohm's law? electric Ohm's law, which is equal to V is equal to R into I. Now, similarly, magnetic Ohm's law we have. And what the magnetic Ohm's law? What is the magnetic Ohm's law? That is MMF, like a VMF. Here we have MMF, which will be equal to, that is Rm into phi. Rm into phi. Now, so MMF, which will be equal to N into phi. So that means N into I, which is equal to Rm into phi. That is Rm, which is equal to N phi by Ni by phi. So this is, now we can say A means ampere, N is a turns by magnetic flux units are Weber. So that is what, tell me now here, ampere turns per Weber. Ampere into second is a unit of ampere into second, that is unit. Ampere into second. Ampere into second means there is a current into time form. So this is I into T form, which has I into T. I into T is nothing but charge, which will be equal to Q. Yes, I into T. This is nothing but charge. So electric charge. Next one. In the circuit, V is the input voltage applied across the capacitor of 2 farads. The current through the capacitor is, okay. Now they given this as current. So here voltage they applied. So they are asking to find the current now. So this is for the capacitor case. The relation is given by what? Tell me now. I is equal to C into dV by dt. I equal to C into differentiation. Capacitance value given as a 2 farads. Okay. Now we need to differentiate this thing now here. Yeah, you can see now first differentiation is nothing but slope of a line. Slope of a line. So if you see, observe the slope of these lines, now here from here to here, the slope which will be equal to plus 10. Next from here to here, the slope is a, okay, this slope is different, I think so. Here this is minus 12 now, that's why it is different. So this point, yeah, this slope is also minus 10 only. Minus 10. So you can tell me now here, T is a, and 10 into 2, 20. It should be, okay, 1 second. This slope is how much, you tell me now, this slope. This point is coordinates, we can say now 1 comma 10. and these coordinates are 3 comma minus 12. Slope of this line is what? Tell me now. Minus 12 minus 10 by 3 minus 1. So which will be equal to minus 22 by 2, which will be equal to minus 11. Minus 11. Yes. So then it will come to be a minus 22. Multiplied with the 2, we should multiply now. So that's why option D. Okay. Then I is equal to C into dV by dt. From that we can simplify it. Yes. Next one. A geyser is operated from 230 volts, 50 Hz cycles per second. That is a frequency given. The frequency of instantaneous power is the frequency of the power frequency that twice the supply frequency, voltage frequency, current frequency. Remember. So this is not power frequency. Power frequency equal to 2 times the voltage frequency. A voltage or current also. Voltage frequency. Yes. Or 2 times the current frequency. So it will come to be a 2 into 50. So which will be equal to 100 Hz. Hz is nothing but cycles per second. So option C. Next one. Next one. Three microfarad capacitors are in series. A 6 microfarad capacitor is in parallel with this series arrangement. The equivalent capacitance of this combination is they given it as what? I mean, now three microfarad capacitors are in series. A 6 microfarad capacitor is in parallel with this series arrangement. So that means they given us what will be now 3 capacitors. These are in series. 3 microfarad capacitors. These are in series. So this is 3 microfarads and 3 microfarads. A 6 microfarad capacitor is in parallel with this series arrangement. So that means the 6 microfarad capacitor is like this. This is 6 microfarad capacitor. Now what they're saying here, equivalent capacitance now here. So this is A and B if I call. So these capacitors are in series. The equivalent of this whole part will becomes as what will be now 1 microfarad and then parallel. So that's why this equivalent is how much we can say now CAB, and which will be equal to 7 microfarads. Next, we have three resistances of values 1, 2, 3. If all the three resistances are to be connected in a circuit, how many different values of equivalent resistance are possible? So that means if n resistances are given, so this how many combinations are possible? If no, if n different resistances and different resistances given are given, number of combinations possible for different equivalent resistance which is equal to power n. Next, if n resistances identical resistances are given, number of possible combinations for different equivalent resistance which will be equal to 2 power n minus 1 and which will be equal to what tell me now here this is. Now here in this case you see what they given now. They given resistances are 1 ohm, 2 ohm and 3 ohm now. All are different. So that means how many combinations now here? This is 2 power n, so that is 2q, which will be equal to 8. Sorry, 8 combinations are possible. Okay, next one. An electric heater draws 100 watts from a 250 volt source. The power drawn from a 200 volt source. The electric heater draws 100 watts from a 250 volt source. The power drawn from a 200 volt source is how much is power they are saying here. The power drawn from the power drawn from a 200 volt source is, yeah, how much we can say now. The power, basically power is given as V square by R. Draws 100 watts from a 250 volt source. The power drawn from 200 volt source is the power which will be directly proportional to V square now. So we can say this as P1 by P2, which will be equal to V1 by V2 all square. Now we can say it as power, which will be equal to 100 by P2, which will be equal to V1, which is equal to 250 by 200. The resistance to same I na. So that's why. So then it will come to be what element of cancellations? 5 fives and this is 5 fours. That is 100 by P2 and which will be equal to what element? 25 by 16. 25, 4 and zeros. That means P2 which will be equal to what we'll get now here. Uh, so that is 640. Right. Next one. Three equal impedances are first connected in delta across a three-phase balanced supply. If the same impedances are connected, in what form here they given? Same impedances are connected in star across the same supply. Now they are asking this is what is the relation of phase current and the uh, uh, load current, line current, sorry, phase currents and line current. Yes, which will be equal to. So the power, so phase current will be 1 by 3 times the previous. No, line current is no. Power consumed will be 1 by 3 times of the previous power. Yes, power, equivalent power. We can see now here power consumed will be a 1 by 3 times of the previous power. Three equal impedance first connected in delta. If the same impedances are connected in star across the same supply. So here, in those cases, power in the delta connection. So here, which will be 3 times the power in star connection. Okay. Power in delta, which will be equal to 3 times of the power in star. So here, they asking what, tell me now here, star connection power na? Star connection power, which will be equal to 1 by 3 times of the power in delta connection. Okay, this thing. Shailendra, yes, tell me. Next one. Current from an AC source bifurcates into two branches A and B in parallel. Branch A is an inductor and a 1 ohm resistance. Branch B is another inductor L and current resistance is 1.5. For the ratio of currents in the branches to be independent of supply frequency, the value of L must be independent, they are saying here. So what they're saying here, they have in one branch inductor and resistor is there. And the another branch we have the inductor, and we have the resistance is also present. So if I call this is now L1, this is R1, and this is L2, this is R2. Now this current is coming like this. Now this current is dividing here. This current is I1 and this current is I2. What they're saying here, for the ratio of the currents in the branches is independent of frequency. Independent of frequency, further the relation is what? Tell me. L1 by L2 must be satisfy this as R1 by R2, independent of frequency. L1 value how much now here? 30 by L2 value we need to get R1 value how much now? 1, R2 value 1.5. So you can get this L2 is equal to what? Tell me now. 1.5 into 30. So this value, how much will come this L2 value? L2 value, so 15, 45 na? 45 micro Henry. For this independent, the condition is what? Tell me now here. L2 value must be 45. Okay. Next one. Three inductors, each of 60 are connected in delta. The value of inductance of each of the arm of star, delta to star conversion. So will come to a same as resistor. Each will become 30. So if you know this thing directly, we can write. So this is, so they given us what? Tell me now. So the delta connection to star connection, resistors and inductors analysis is same only. Here we have inductor we have taken. All these values are 60. Each one is 60, 60, 60. And this is also 60. Now here we need this one, we need, let us say here this inductance if I want. Yeah, tell me now L1 equal to what I can say now, 60 into 60 by sum of all, that is 60 plus 60 plus 60. So that is L1 will come to be as 60 into 60 by what? Tell me now, 3 into 60. So 60 will get cancelled, which will be equal to, sorry, 20 na? Sorry, 20, not 60, 20 by 3 na? 20, sorry. Next one. Which one of the following is a valid value of coefficient of coupling? Coefficient of coupling should be always less between 0 to 1. Remember, 0 less than or equal to k less than or equal to 1. It should be less between 0 to 1. More than 1, it is not acceptable. So then this is only the value. Two coupled coils connected in series have an equivalent inductance 16 or 18 depending on the connections. Okay, the inductance between them is okay. So that means mutual inductance is there. So that means if they connected in a aiding manner, so L1 plus L2 minus 2m, this value, sorry, plus 2m, this value is given as 16, and both values of two coupled coils have same inductance. So this value 2L plus 2M, L1, L2 both are equal, that is a 16. So L plus M, and which will be equal to what? Tell me now, 8. L plus M is equal to 8. Next we can say now this is L1 plus L2 minus 2M, which is equal to 8. That means 2 into L plus M, and which will be equal to what element of 8 only. 8 only. That means L minus M, which is equal to how much now? 4. So we got the L plus M we have. L plus M is equal to 8. L minus M is equal to 4. If you subtract now, minus, this is plus, this is minus. So we'll come it as a 2M, which is equal to 4. So that means M is equal to what? Tell me now, 2 millihenry. Next one. Tesla is a unit of magnetic flux density. Magnetic flux density, that is given as flux. Magnetic flux by area. And the units are what? Tell me now. One unit is Weber per meter square. And Weber per meter square is also called as a Tesla. Weber per meter square, which is also called as a Tesla. Okay, fine. Okay, fine. Yeah, that's it for today's class, and next class will continue remaining topics. Okay, then.